Hello everyone, welcome to the lesson on geometric solids. These are solid figures. This is our last unit of new material for the year. So let's take a look at these. A sphere, the ball, okay. A cube, it's a three-dimensional figure. The all dimensions are the same. So the length, the width, and the height are all the same. A cylinder is has a circular top and bottom, that congruent circles, and then you have this here, which is the height of the cylinder, okay? You have the height of the cylinder here, okay? So it's important to remember when you're looking for the area of a circle, you need the radius, not the diameter, okay? A prism is basically a box, like a box of tissues, okay? Length, width, and height are not all the same. So a cube is really a special case prism, all right? You have a pyramid. We'll be dealing with what we call a regular pyramid, where the bottom is a square. And you've got a cone. And the cone again has a circular base. So again, when you're looking for the area of the base, you want the radius, okay? This here, this is called the slant height. Slant height. The same thing here in a pyramid. Let me go back to here. From the point to the top of the pyramid, it intersects the square base right in the middle of the base, okay? So you have a height, right? You have this, and this is the slant height here. And you'll see in some of the problems why you need a slant height, okay? You have to remember the pyramid and the cone from the point perpendicular to the base, it intersects the center of the base, whatever it is, whether it's a square or a cone. All right. So let's talk about prism. Has parallel faces called the bases. Okay. Opposite sides, all three sets of opposite sides are parallel, and they're congruent. Okay. The lateral face. The lateral face is what you see when you look on it straight on. So when you're looking at the lateral face of, let's say, a box of tissues, you're not seeing the top and the bottom of the sides. You're seeing it straight on. Okay? Whatever that face is, it's a rectangle, it's a square. All right? That's your lateral face. All right? We'll be dealing mostly with right prisms. Okay? So they're all right angles here. All right? Even if it has triangular base, like this one here, the height is perpendicular. Okay, so in a cube, all faces are congruent squares. In a prism, the faces are rectangles. Now we talk about this thing called edges. Okay, you have an edge when two surfaces are meeting each other. Okay. So this edge is the back and the side, all right? You have an edge here, right? You have a lot of edges. This is the front and the top are meeting at an edge, okay? That's different than a vertex, right? This here, you have a lot of vertices here. So this is a vertex here because you have a bottom and a side and a front and a side meeting, okay? This is a vertex here because you have the top meeting the front, meeting the side. Right? So you have three edges meet at a point. That's a vertex. Volume. Let's talk about volume. Volume is what it can hold. Okay. So a cereal box, it's got a volume, right? Tissues has a volume. Anything that's a box. So the volume is the area of the bottom, right? The area of the base, whatever that shape is, rectangle, square, triangle, as in this one here, all right, times the height. So you figure out the area of the bottom, multiply by the height. That's the volume of a prism. Pyramid. You have congruent isosceles triangles making up the slants of the pyramid. Okay, the base is a square. All right. The volume of a pyramid is 1/3 the product of the base times the height. So, on a pyramid, the base is going to be a square. So, area of a square equals side squared. Okay? So, 1/3 the area of the bottom, which is a square, times the height. Alright? Again, this is another diagram showing that the height or the altitude of a pyramid goes from the point to the center of the base. Okay? A cylinder. The base is a congruent circles. It's like a can of corn, big can of oatmeal, the big canister of oatmeal, those things, all right? Your water bottles, right? Depending on the kind of water bottle, those are cylinders, okay? So since the bottom is a circle, you have pi r squared, and then you have the height. That's the volume of a cylinder. Pi r squared, the area of the base, times the height. A cone has a circular bottom. Okay. You have the slant height of the cone, you have the circular bottom, you have the radius, and you have the height or the altitude of the cone. Okay. So the volume of a cone is the same as it would be for a pyramid. It's 1/3 the area of the bottom. In this case, it's a circle, not a square, right? So 1/3 pi r squared times the height. That's the volume of a cone. And then we have a sphere. We're not really going to be looking at surface area too much. All right. I left it in there in case we come across that. But the volume of a sphere is 4/3 pi r cubed. Okay. The unit of measure on volume problems, they're cubic units because you're multiplying 3 dimensions. Okay. Base times width, length times width times height in a sphere, in a cylinder, pi r squared, radius squared times height. You're multiplying 3 dimensions, right? Radius times height. So this one, it's 4/3 pi r cubed. It's radius cubed times pi times 4/3. That's the volume of a sphere. Okay. A great circle is the largest circle that can be drawn on a sphere. All right, and we're going to come across an interesting question about that. We have to think about it a little bit. So when you have a plane, let's say you're going to take a slice through a sphere. If you slice it off and you take that, you get a circle, right? So if you cut through this and you take off the piece you cut, you have a circle. One little tidbit: if 2 planes are equidistant from the center of the sphere, then the circles are congruent. Okay, one little tidbit of information there. All right, so these are the basic shapes. We're actually going to look at maybe one more shape after this, but there's a separate lesson for that. Okay, so let's go through this. All right, you have a cube. Side length of 9 feet. So the volume of a cube is side cubed. So the volume is 9 cubed. Now it's a calculator problem. Grab your calculators out. And 9 cubed is 729. And it's going to be cubic feet. Let me, kind of sloppy there. cubic feet, or you could say feet cubed. Okay. Rectangular prism. You're going to multiply the length times the width times the height. So the volume is length times width times height. 9 times 6 times 11. So the volume of this prism is 594 cubic centimeters, or centimeters cubed. Okay. Pyramid, height of 9 and a base with a side of 10. So the area of the base. Is 10 squared, or 100 square inches. Okay. Volume. Always start out by writing the formula out. Okay. I'll tell you why. On a free response test or quiz, if you write the formula out and you put the right numbers in and you get the wrong answer, that just means that you used the calculator wrong. Okay. Different kind of mistake. So get in the habit of where did that come from? Get in the habit of writing out your formula. So volume is 1/3. Where's my pen? 1/3 area of the base, capital B, times the height. 1/3 times 100 times 8. Let me get my calculator out. I didn't do this problem yet. Volume is 266.67. Inches cubed. Okay. Once you write the formula out, it's a calculator problem. All right. Last one. Oh, we have two left. Volume of the cylinder. Volume is the area of the circular base, pi r squared, times the height. Volume is, pi times 3 squared times 5. Now it says to the nearest hundredth of a cubic centimeter. So you're going to round your answer to 2 decimal places. So you run that through the calculator, and you can use the pi button. Don't multiply by 3.14, use the pi button. So it's 141.37 cubic centimeters. That's the volume of that cylinder. Okay. Last one. Volume of the cube. This one, the diameter is 8. Radius is 4. You got to remember the formula is looking for the radius. Volume is 1/3 pi r squared times height. 1/3 times pi times 4 squared times 12. Go to your calculator. It says to the nearest cubic inch, so make sure you round it correctly. It's 201 inches cubed. That's rounded to the nearest cubic inch. Okay. So the last thing I put in here, this is the reference sheet that you would be getting on the Regents exam. So all the formulas are on the reference sheet. So when you print this lesson, maybe you want to print that and hold it off on the side as you work through the classwork for the next few days. Okay. So thank you for tuning in to the lesson on geometric solids. Okay. Remember, We're looking at volume, which is what a figure can hold, a three-dimensional figure, okay? Which is how much can you put inside it, right? So thank you for tuning in to the lesson on geometric solids. And this lesson was brought directly to you from my dining room table.